So the limit definition of the derivative. So what the derivative finds is several different things. It finds the slope of a tangent line at one instance in time. It also finds the instantaneous velocity. And there's two different formulas that are applied here. This first one will give you a generalized function like f prime of x is what they're going to call it, the new derivative formula. And this one would be f prime at a specific value, a overall. And it really should come down to practice of seeing what these are going to be doing. So in its most basic form, I'm going to go ahead and deal with y equals x squared, or rather f of x equals x squared. And you might be asked, what is the derivative using limit definition? So I would do the limit as h approaches 0 of f of x plus h minus f of x all over h. And all these limits, by the way, all of these are indeterminate forms, which means they're all going to give you some form of like 0 over 0. Your goal is going to be to simplify. So if I go and plug in here, I'm going to get x plus h squared minus the original function, x squared all over h. Go ahead and continue to FOIL that out. Minus x squared all over h. The x squares cancel, leaving you with the top having an h in common that you can factor out, 2x plus h over h. Limit as h approaches 0. Once you reduce, go ahead and substitute back in as 0 for h. So I'm plugging in a 0 right there. All right, and that'll just give me 2x. Okay, so what is that? That's the derivative. That's going to be the equation to find all the slopes of all the tangent lines to the original function. So the original function, x squared, looks something like the following. And if you were asked several different questions, for example, given the derivative now, if I ask you, like, what's f prime of 1, you plug in 1, that gives you a 2. Which means at x equals 1 on the original graph, f of x, the slope of the tangent line is going to be equal to 2. If I gave you f prime of negative 2, 2 times negative 2 is negative 4, which means at x equals negative 2 on the original function, x squared, that tangent line, and I can draw a better one than that tangent line is going to give you a slope of negative 4. So this new function gives you all the slopes of all the tangent lines to the original function. Now, the other formula does it for a specific point. And in fact, both of these can. So if I want to go ahead and do another example here, let's say I asked you to go ahead and find, for instance, again, using limits, let's do f of x equals 1 over x, and we'll go and find f prime of 2, again, using the limit definition. So one way to do this is a limit as x approaches 2 of f of x minus f of 2 over x minus 2. Again, if it was 3, you would put a 3 and a 3. Limit as x approaches 2 of 1 over x minus 1 over 2 over x minus 2. And we're going back to these indeterminate forms. We have a complex fraction, so you multiply them by each other. Limit as x approaches 2 of 2 times 1 is 2 minus 1 times x is x, all over 2x. Divided by x minus 2 is times 1 over x minus 2. You can cross those off as long as you factor out a negative 1. And once you do, you plug in a 2 for x, and you get negative 1 over 4. Which again, what this means is the original function, 1 over x, is the reciprocal function, looks something like this. At x equals 2, the tangent line on the graph is going to look something like this. So they could ask you to find a general function. They could ask you to find a slope. They could even ask you, what is the equation of this line itself? And to find the equation, well, you already have the slope. So the slope is negative 1/4. The point would come from the original function. So you'd have f of 2 is equal to 1/2. And then once you have slope, once you have a point, you can do point slope form and find the equation of the line. And those are several applications you may encounter when dealing with the limit definition of the derivative. And let's go ahead and finish this one up. So ready? Let's see, 2 comma 1/2, and the slope is negative 1/4. So again, 2 comma 1/2 is the point. The slope is negative 1/4. So y minus my y coordinate equals m x minus my x coordinate. Distribute. Negative 1/4 x plus 1/2. Add the 1/2 over, and that was the equation of the tangent line from the last slide.